This video is about learning outcome number 4, which is all about applying the empirical rule when appropriate to estimate the percentage of data values that lie within a given range. So here's the empirical rule. It's very important that you understand that this is appropriate only for data sets that have a distribution that is approximately bell-shaped. So we want our distribution to be approximately normal. Remember we talked about that low, high, low pattern in the symmetry? That's what we mean whenever we talk about bell-shaped distributions. Here's how it works. If you have an approximately normal distribution, 68% of all of the values will fall within one standard deviation of the mean. So the mean is right here. And if I add the standard deviation and I subtract the standard deviation, 68%, or a little bit more than 68% of those values will lie within that one standard deviation of the mean. If we start at the mean and then we add and subtract 2 standard deviations, it turns out that 95% of all data values will lie within 2 standard deviations of the mean if the data is approximately normal, or the distribution is approximately a normal or bell-shaped. And then about 99.7%, almost 100%, 99.7% of all values fall within 3 standard deviations of the mean. So we've got the mean here. We add this standard deviation 3 times. We subtract the standard deviation 3 times. And it turns out that 99.7% of all values will fall within that range, provided that the data sets have a distribution that is approximately normal or approximately bell-shaped like this. So this is just the exact same graphic, just larger. So we've got that 68% in the middle, or that 95% in the middle within 2 standard deviations, or that 99.7% in the middle within 3 standard deviations of the mean. So let's apply this. We've got an example problem. It says IQ scores have a bell-shaped distribution. Okay, so the empirical rule applies, with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? Well, in order to do this, we need to know how many standard deviations away from the mean 70 and 130 are. So the first thing I would like to do is draw that distribution. I'll do this on my paper. So we've got IQ scores, and they have a distribution like this. And they told us that the mean was 100, and the standard deviation is 15. So we add 15, so that's the mean plus 1 standard deviation, and we subtract 15, that's 85, that's the mean minus 1 standard deviation. So this isn't a perfect graph, it should be more symmetrical. But in here, within 1 standard deviation of the mean, so that's all IQ scores between 85 and 115, turns out approximately 68% of all IQ scores lie within this range. But they didn't ask about 85 and 115, they asked about 70 and 130. And actually 70 and 130 are the values that we get next if we add another standard deviation here, and we subtract another standard deviation here. So that is within 2 standard deviations of the mean. And within 2 standard deviations of the mean, we have about 95% of all data. So that means 95% of individuals, if this is all accurate, have IQ scores between 70 and 130. That middle 95%, that's within 2 standard deviations of the mean, according to the empirical rule, if IQ scores are normally distributed, which means they have this bell-shaped distribution, 95% of data values lie in here. And that's what they asked us. So let's go back to our slides. We'll see how that looks on the slides. It says the key is to recognize that 70 and 130 are exactly 2 standard deviations away from the mean, which is 100. So we subtract 2 standard deviations and we end up at 70. And we add 2 standard deviations and we end up at 30. Since we're within 2 standard deviations of the mean, The empirical rule tells us that that means 95% of all IQ scores lie between those two numbers. So that's it for the empirical rule. See you in the next video.